A magnetic dipole is under the influence of two magnetic fields. A magnetic dipole is under the influence of two magnetic fields. The angle between the field directions is 60 degree. One of the fields has the magnitude of 1.2 into 10 power 2, that is 10 square Tesla. If the dipole comes to stable equilibrium at an angle of 15 degree with this field, what is the magnitude of the other field? So this problem is based on which concept? That is magnetic field, magnetic dipole kept in external uniform magnetic field. So please make a note of it, the concept. The magnetic dipole under the, that is kept in, that is present in the external magnetic field, uniform magnetic field. So this is the concept. You know very well, when a magnetic dipole is present in external magnetic field, there will be a torque. So that is the first idea. Now what they have given here, a magnetic dipole, two magnetic fields. It means B1, B2. Take down B1 and B2. The angle between the field is 60 degree, another at 15 degree, it is in equilibrium. So it deals with the two different angles. So one is theta 1, we can say theta 1. The other one is theta 2. Okay, right. Now, so here let me call it theta 2. We have got two different angles. And one of the fields has the magnitude. So the magnitude of one of the fields, let me say that is B1. Its magnitude means its scalar quantity. How much? That is 1.2 into 10 squared Tesla. Okay, right. So one thing is clear. The concept is this one. That is magnetic field dipole present in external magnetic field. The other one is here at stable equilibrium. The dipole comes to stable equilibrium at which angle? That is 15 degree. So stable equilibrium means what? The twist, that is the torque, okay, is equal. So tau 1 is equal to tau 2. This is second important concept, right? We know already this tau is nothing but that is mb sine theta. Is it not? So mb sine theta. So we are going to use these three key points here. Okay. Now let us proceed with the solution. So first of all, what are given here? Let us note down one by one. Given and what we need to find. So should be written here. And let us proceed with the steps here. That is solution. Okay. Right. So given, what is given here? B1, B2. Here tau 1 is equal to tau 2 and that indicates so this one stable equilibrium means what? Tau 1 is equal to tau 2. So whenever you look at the problem, you should be able to identify the important parameters that are represented as symbols. So once you are able to symbolize all these parameters given in the problem, you can easily arrive at the that is concept and easily substitute in the relevant formulas also. For instance, given here, what are given here? B1, B2. So B1 is given. There are two fields. One of the field is given. One of the fields is given. What is that? 1.2 into 10 power 2 Tesla, 10 squared Tesla. And another thing is tau 1 is equal to tau 2. That is the clue given here. What is tau 1? Tau means what? What is tau? That is mp sin theta. What is tau? Torque. That is nothing but torque here. Okay. Torque. That is the twisting force. Okay. And it is expressed by tau is equal to mb sin theta. And what is m here? What is m? What is m? Pole strength. And b, magnetic field. Okay. Now let us substitute this. Tau. I mean, this tau is equal to tau. Instead of tau, you can write tau 1 is equal to what is that? M1 B1 and then sine theta 1. Okay. In fact, the magnetic pole strength remains the same because we are using the same magnet. So in that case, M1 is equal to M2. So this is regarding the tau 2, that is M2 B2 sine theta 2. Okay, right? Now, so M1 is equal to M2, and here tau 2 is equal to M2 B2 sine theta 2. Okay, so in that case, now this M1 is equal to M2. You can simply put M. Okay, so these are the steps we have to follow. And what are the other parameters given here? Theta 1 is given. Okay, let us note down theta 1. And this theta 1 is how much? That is at 15 degree. So you have to state this as theta 1. Okay, let us consider this as theta 2. So at this angle, that is the tau 1 is equal to tau 2. It means theta 1 is equal to 15 degree theta. So 15 degree. 15 degree. Okay. Now, what is the initial the angle between the field and the direction is 60 degree. So that is the initial one. So you can take this as theta 1, theta 2. So theta 2 we had to find out. Initially it was 60 degree and at 15 degree it has got that equilibrium. So you have to put 16 degree minus 15 degree. That is equal to 45 degree. So theta 2 is equal to 45 degree here. Okay, you got it? Right. Now we can substitute in this equation. Okay, so from this, the other field can be easily identified here or determined. Okay, now what we have got this equation tau 1 is equal to tau 2. And what is this tau 1? The tau 1 is m1, m b1 sine theta 1. M b1 sine theta 1 is equal to m b2 sine theta 2, right? So m can be cancelled. What is our interest? B2. So B2 is equal to what? B2 is equal to B1, is it not? Into sine theta 1 divided by sine theta 2. Got it? So that is equal to, and what is the value of B1 here? B1 is, so this is the derived equation. From this, we can easily substitute and get the answer. So what is this? 1.2. So 1.2 into 10 square into and sine theta 1. So what is sine theta 1? Sine 15 degree. Actually, that is, yeah. So it should be whether it is a 10 squared or 10 power minus 2, 10 squared. Okay. So here, sine theta, what is the theta 1? Theta 1, 15 degree. Because at that degree, it was at the equilibrium. 15 degree divided by sine 45 degree. Okay, got it. Now 1.2 into 10 squared, and you can refer to sine table in the logarithm table. Okay, So the sine table according to this is how much? 0.2588. You can check with the logarithm, otherwise you can use the calculator. But you will be provided the logarithm book. From this you can find out. There will be a separate trigonometric table for that. Okay. Then sine 45, what is that? 1 by root 2. So 1 by root 2 means what? 1 by root 2. You can work out 1 by root 2. So 1 by root 2 means root 2 by root 2. That is root 2 divided by 2. So 1.414 divided by 2. That is a point, how much? 702 7. Okay. 14, then 0, then 7. Correct. So 707. So you can put 707. 0.7 0.707. So 1.2. Can you get me the calculator? 0.2588 divided by 0.707 is equal to 0.366 into 1.2. That is equal to 0.439. So 0.4393, okay, into 10 square. So it means 43.93 Tesla, because it is the field. So the other field is D2 is equal to 43.93. Okay.